If D is the event that a person has a condition and plus or minus the event that a test for the condition returns a positive or negative result, then the probability a person has a positive result given that they have the condition is the sensitivity of the test, and the probability the test returns a negative result given that the person doesn't have the condition is the specificity of the test. But if we're testing a person, then presumably we don't know whether they have the condition or not, so these probabilities are irrelevant. What we know is whether the test result is positive or negative. So what we need to know is the probability that a person who tests positive has the condition, and the probability that a person who tests negative does not have the condition. To find these, we need one more factor, the prevalence, sometimes called the base rate. What fraction of those tested have the condition? For example, suppose we have a COVID test that's 99% sensitive and 95% specific, and 2% of the population tested has COVID. We'll use a tree diagram. Since both sensitivity and specificity require us to know whether or not a person has the condition, we'll start with the prevalence. In our first branch, 2% of those tested will have COVID, and 98% won't. Now, both sensitivity and specificity can be viewed as the probability of returning the correct result. Of those who have COVID, the correct result is positive, so 99% will test positive and 1% will test negative. Of those who don't have COVID, the correct result is negative, so 95% will test negative and the rest will test positive. Since we're using percentages twice, let's assume we test 10,000 people. Since 2% of those tested have COVID, then we know that 2% of 10,000, that's 200, have COVID, and the remaining 9,800 do not. Now that we know how many actually have COVID and should test positive, we can then use the sensitivity. Since the test is 99% sensitive, then 99% of 200, that's 198, will test positive, while the remaining 2 will test negative. We also know there are 9,800 who don't have COVID. The specificity applies to these people. 95% of them will test negative, while the remaining will test positive. And from our tree diagram, we see that 688 have a positive test result. There are 198 people who have the disease and test positive, so there are 198 true positives. But there are also 490 who don't have the disease but still test positive, and so there are 490 false positives. Note that in this case there are significantly more false positives than true positives, and in fact most of the positive results are in fact incorrect. And we can say that the probability that a person has the disease, given that they had a positive test result, that's just this 198 out of the 688, or about 29%. We also see that there's 9,312 negative results, so the probability that they don't have the disease, given that they had a negative test result, that's these 9,310 people who don't have the disease out of a total of 9,312 who tested negative, or pretty close to certainty. Now, the fact that the probability a person has the disease given that they tested positive is pretty low means that even with a positive test result, we have relatively low confidence that the person has the disease. It's worth noting that the unconditioned probability a person has the disease is 0.02. So even though this probability is low, we are more confident with a positive test result that they have the disease. On the other hand, the probability a person does not have COVID given that they have a negative test result is pretty close to 1, so a negative test result should give us high confidence that the person does not have the disease. It's important to imagine what this means in the real world. If a person tests negative for COVID, there's a very high probability they don't have the disease, so it's reasonable to act as if they don't have the disease. But if a person tests positive for COVID, the probability they have the disease is low. But it might still be reasonable to act as if they have the disease, depending on what those actions are. They might wear a mask if they're with other people, they might stay home from work, they might avoid family gatherings. If they don't have COVID, these precautions are unnecessary, but not particularly troublesome.